Okay, I wanted to just do a quick video showing how I generated the toolpath to surface veneer. This is a really simple process for this program, but it's as I've thought that this is kind of like moving an anthill with a bulldozer. This program is so incredibly powerful, but it is free for non-commercial use, which is great. So I think this is a fairly simple process for this program, but I'm just learning, so I felt a sense of accomplishment learning how to do it. So we're in the model workspace to start with, and we're going to create a box what you want to do is create a model of the final piece that you want to end up with. So I'm going to build it on the bottom plane here, and just pick the origin as my first corner. And then just as an example, I'm going to make a box that's 100 by 50. Let's see, 100 long in the x-axis on the x-carve and 50 deep in the y-axis. Okay. Now the z-axis is where you have to think about it a little bit. I'm using Baltic birch plywood, which is 12 millimeters thick, and I'm going to glue a 2 millimeter sawn veneer onto that. So the total thickness to start with is going to be 14 millimeters. And then I want the x-carve to mill off at 1 millimeter. So my final piece will end up being 13 millimeters thick. So that's what I'm doing. I'm building a model of my final piece. Okay, so that's that. Now that's all I need to do since this is such a simple thing that I'm building here. Just a little sample of veneer. So now I'm going to switch to the CAM workspace. And this is where I'm going to generate my toolpath. The first thing I want to do is do a setup. And this is going to tell the machine about the stock orientation, tell the software about how the machine's oriented and so forth. First thing I want to do is set my orientation. This is a milling, not a lathe operation. My model orientation, if you look here, you can see that it has the z-axis going forward and the y-axis going up. We don't want that, right? That's not the way the x-carve is oriented. So I'm going to switch to select z-axis and pick it there, and then it'll end up with the right orientation. Z is going up, Y is going this direction, and X is going this direction. Now I need to know where the origin is. Now I know easel uses the top of the stock as the origin in the Z, and then the point that's sort of all the way to the left and to the front. Since the top of my stock is the rough part that I'm milling off, I want to pick the bottom as my reference surface. So I'm going to pick a stock point on the stock as my reference point. Okay, my 0, 0, 0. So I'm just going to pick this one here, and there we go. Okay, now you'll notice it has the stock sort of drawn in this ghost around the final piece, and it has extra stock on the bottom and the sides. That's not the way my piece is. It's just I've got the extra stock on the top, the veneer. So I just need to go to the stock tab now and fix that. So I'm going to use actually relative size, where it just adds stock to each dimension of the model. And I don't need anything added to the sides, just the top. And I only need a millimeter added to the top because that's how much I want to mill off. Okay, so got that. That's good. Now the post process, I know what post-processing is, but I don't know why it's here. So that's something I've yet to learn. So we're done there. Now we're going to go to operations. So we're going to do a facing operation in 2D. Okay, I'm going to select a tool. It's got a ton of different tools here. I'm just using a 2-flute 1/4 inch end mill that's flat on the bottom. So I'm going to pick flat end mill and going to pick 1/4 inch. Now you'll see there's a lot of different 1/4 inch ones in this list. Doesn't really matter. All we really care about at this point is the diameter. So I'm going to pick that. I don't care about workpiece material. That's setting the speeds and all. And I'm going to set those manually. So it doesn't matter. Okay. All right. You can see the spindle speed there and surface speed. I don't have my X-carve set up to turn the spindle on and set the speed yet. I'm working on that, but I haven't done it yet. So I'm just going to ignore that for now. I'm also going to disable the coolant. It doesn't really matter. I don't have a coolant system. Okay, so all I really care about is the cutting feed rate. So I'm going to set these all to 1,000 millimeters a minute, which is plenty fine for milling off such a small piece. There's a lot of different feed rates you can do here. You can slow it down on the lead in and lead out if you want to, speed it up. Might find uses for that in the future, but right now I'm just doing everything as one rate. Now the plunge feed rate, I'm not actually going to be plunging into the stock, so it doesn't really matter, but just for a good measure I'm going to slow it down to 100. Doesn't really matter, it's such a small amount that I'm feeding. Okay, next is the geometry, what I'm actually cutting. It's already picked the right surface, so it doesn't matter. Heights, these are just the heights for clearance and for retraction. The stock ones seem to work fine. This is where I want to pay a little bit of attention. My passes and direction and so forth. First of all, pass extension. I want it to go past the stock so that I'm not actually going to be plunging into the stock. I'm going to be cutting from the side and get a better finish that way. So I'm going to have it go past the stock by about the diameter of the bit, which is around 6 millimeters. Okay. The step over, that's how much it steps over in the laterally with each pass. This is the diameter of the bit. Don't really trust it to be that accurate, so I'm going to step over about 5 millimeters. Here's the direction, where you can pick which direction it's going to cut, and I'm choosing climb cut it only, which allegedly has a better finish. I haven't tested that yet though, but might as well use it. Multiple depths, this is another important thing. I'm not going to take off the whole millimeter at once. I'm going to do it in steps. So I'm going to do, because I don't want to tear out the figured grain. That's the idea. I'm going to have maybe 1/2 millimeter to start with, and then do a finishing step of only 0.1 millimeter. Okay, and then you can even slow it down on the finish feed, which I'll do just for grins. All right, and that's that. Now it's going to generate the tool path, and it's done so. You can go up and simulate if you want to. I'm not going to do that at this point, but you can choose simulate, and it'll show you a little animation of it moving. I do want to mention that you should save this at this point. I've had a few crashes. This is software that's being continuously updated, so had a few crashes with it, so I'm going to go ahead and save this as test piece veneer. Okay, so now it's saved. I'm good to go. I'm going to go to Actions and Post Process. This is where it's crashed in the past. Oh, good. All right. So it has a generic post processor that does Gerbil. You can see there's a whole bunch of post processors for different machines and stuff, but I'm just picking the generic Gerbil one. You do want to, we're going to open it in our file editor to make a few changes afterwards. You do want to go into the properties and just make sure that these boxes are unchecked, especially to use G28, which is the homing command. I broke all my my homing switches on my machine, so I don't do that anymore. I don't really think it's that useful, but I just uncheck that so it doesn't put those in there. And then we just click OK, and it's going to generate our G-code file. I save mine to the Dropbox and then download it to the machine that's running my X-Carve, but I'm just going to say this is test veneer.nc. Okay, now it's going to open up this program Brackets that it installs. I don't know what it does on Windows, but here in Mac it installs this bracket one. And now we can just start to pull out the stuff we don't need. All these comments and so forth, I don't really need those. Get rid of those. That's a comment. The M commands, I think that's to turn the coolant off, which I don't even have, so why have it? That's to turn the spindle on at the right speed there. Okay, we don't really need that, so I'm going to get rid of that one. And then there's M9, that's tool change. We're not doing, I don't have a tool changer, so I don't need that. Okay, so then we can go down to the bottom, and we got a few more of those things I don't need. M30 is end of program, M9 is, I think, the tool change again. Don't need that. Okay, so that should be good. So we just go to File, Save. And that's our final G-code. Just load that up into Universal G-code Center. Make sure that you set your X and Y axis in the bottom left-hand corner, and that you set your Z-axis 0 off of your work table, and you'll be good to go.